Hello, everybody. Okay, so Wednesday, we are determining the least common denominator. We're preparing ourselves to eventually add or subtract fractions. So I've started with, as an example, two fractions, 1/2 and 2/5. Now, the rule is with fractions, you cannot add or subtract fractions unless there is a common denominator. Okay, your denominator is the number on the bottom. Okay, so if you were to divide a shape into parts, this would be a total of 2 parts. So one of 2 parts are shaded. Or this numerator, 2 of 5 parts are shaded. Okay, so bottom number is your denominator, top number is your numerator. Now, we need to find a common denominator in order to eventually add or subtract. So what are the steps? You're going to take your two denominators, the 2 and the 5, and I've circled them just so you can see them, and I've placed them down here. So step number 1 is you're going to create a table, and you're just going to basically do multiples of each of these numbers, which means 2 times 1, 2 times 2, 2 times 3, etc. So if I were to skip count by 2s, I would get 2, 4, 6, 8, 10. I stopped there. I went to the 5s and I skip counted by 5s. 5, 10, 15, 20. Okay? Now, I don't really have to go any farther than this because what I'm looking for is what do 2 and 5 have in common as far as a multiple? I don't see anything common here. 4 and 10, they don't have anything in common. 6 and 15, I don't see anything. 8 and 20, I don't see anything. But now I hit this 10. They have 10 in common, right? 2 times 5 is 10, and 5 times 2 is 10. So this is the least common denominator, or the least common multiple. They have that multiple in common, okay? So the third step is going to be changing each fraction to an equivalent fraction. Let me go back here and use this one. By using the multiplication identity property of 1. And as we have reviewed before, fractions can represent whole numbers. If I were to create a box or a rectangle and put it into 2 parts, and I shaded in all 2 parts, 1 whole is shaded. Same thing with the fraction 4 over 4. If I create a shape of 4, right, 4 parts, and I shade in all 4, what have I done? I've shaded in 1 whole. Okay, so as long as your numerator and your denominator are the same, that still represents whole number 1. So keeping that in mind, the step would be then to multiply each fraction, so our 1/2 and our 2/5, and we're going to multiply each fraction so that the denominator becomes this least common multiple, which in this instance is the number 10. Okay, so how have I done that? Let me go ahead and start back here. So I have 1/2, and the common denominator is 10. So I need to make this 2 a 10. How do I get there? I have to think to myself, well, what number multiplied by 2 gets to 10? 2 times 5 is 10. And if I'm using the identity property of 1, 5 over 5 means the same thing as 1. I'm just breaking it apart into pieces so that I can change this 1/2 into tenths. Okay? 5 over 5 means 1. So I'm not changing the value of my half. Okay, so 2 times 5 is 10. Now, whatever I do on the bottom, I've got to do on the top. And again, this is still representative of 1, right? So 5 over 5. So 1 times 5 becomes 5. So 1/2 and 5 tenths are the same thing. Okay, so if I were to create a shape, right, of 1/2, this is what it looks like. If I were to create the same shape and make 10 parts and shade in half, right, 5 out of 10, it's the same. Okay, all right, now over here, 2/5. How do I change 2/5 so that this denominator becomes a 10? So my 5, I want it to become a 10. How do I do it? 5 times the number 2 is 10. So I use that identity property of 1, right? So I create a fraction, 2 over 2. That means 1. If I'm multiplying 2/5 times whole number 1, I'm not changing the value of this fraction. So 5 times 2 is 10. 2 times 2 is 4. So now I've created fractions that are equivalent. And then as we move forward, we can simply add or subtract these fractions. Okay? So what we're going to do is we are going to practice this again. So I have the fraction 1/4 and I have the fraction 1/3. So I'm going to create a chart using these numbers, a 4 and a 3. So I'm just going to skip count by 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. I'm going to just stop there. I'm going to move on to the 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. See how knowing our multiplication tables makes my life easy? Okay, now I'm looking for a common multiple. Oh, there it is, 12 and 12. That's my common multiple. I want these fractions to become a 12. Okay, the denominator to become a 12. So how do I make the 4th become a 12? Using the identity property, we're going to multiply it by 1, but we're going to break this 1 up and we're going to change it into a fraction. So 4 times what number makes 12? 4 times 3. So my fraction becomes 3 over 3, right? 3 over 3 means 1 whole. Okay, now I simply multiply across. 4 times 3 is 12. 1 times 3 is 3. So 1/4 is the same thing as 3/12. And then I'm going to do the same thing here. I want my common denominator to be 12. How do I make the 3 become a 12? 3 times what number makes 12? Again, I'm multiplying by the number 1, so I'm not changing the value, but I'm breaking this apart into a fraction. 3 times 4 is 12. So I'm going to say 4 over 4, which still means 1. Okay, so 3 times 4 is 12. 1 times 4 is 4. Now I've created fractions with the same denominator, but the values are equivalent. These fractions are equivalent. Okay? All right, I'm going to do one more here. So 3/4 and 1/9. I'm going to create a table with my denominator. 4, 8, 12, 16, 20, 24. Okay. I'm going to do the same thing here with my 9s. I started up there. 9, 18, 27. Ooh, I don't see anything yet, huh? 36. Okay, so I have to keep going here with my 4s. 24, 28, 32, 36. Okay, 36 is the least common or multiple. Okay, nothing else here is the same. So I'm going to convert both of these fractions so that the denominator becomes 36. Okay, so I'm going to multiply this fraction by an equivalent of 1, right? 4 times what number makes 36? It's 4 times 9. So I'm going to create an equivalent fraction to 1, which is 9 over 9. 4 times 9 is 36. 3 times 9 is 27. Okay, so 3/4 is the same thing as 27 over 36. And then I'm going to do the same thing with my 9s. 9 times what number is 36? It's 4. So I'm going to multiply this fraction by 4 over 4, right? This still means 1. 9 times 4 is 36. 1 times 4 is 4. So I have created two fractions now that have a common denominator. These fractions are equivalent. I just broke them up into smaller pieces so that they have something in common. Okay? All right, guys. We'll see you later.